Greetings everyone. Today we're going to explore solving rational equations. Now, we previously solved rational equations when there was a single rational equal to a single rational, meaning fraction equal to fraction, and so we cross multiplied. So see that video if needed. Today we're expanding by adding in an element of addition or subtraction into our equation. So let's go back a long time ago when I had equations like this, right? Our goal was a common denominator. So we decided what that would be. In this case, my LCD was 18. And we multiplied each fraction by what it needed. To get 3 to 18, it needed a 6. To get 9 to 18, it needed a 2. So we would have had 6/18 x plus 10/18 x, or excuse me, 10/18 equals 17/18. And then we just followed the rules of solving, right? Like I'm going to subtract this to the other side because that would be the next step to get 7/18. And it's equal to 6/18 x. Instead of dividing by a fraction, we multiplied by the reciprocal, right? We're still going to have this process. That would get x by itself, and the 18s would cancel, and I'd be left with 7/6. So we want to approach it with the same idea of rules. The difference now is we're going to have expressions in our numerator and denominator. So let's start really small. So there's no really rules to jot down on this. We are combining all of the rules we've been working on so far. So first thing I'm going to do, I'm going to continue to identify my LCD. It's each piece of the denominator once. So in this case, a 2x would cover that. The first fraction has a 2, it needs an x. The second fraction has an x in the denominator, it needs a 2. And the third fraction has an x, so it needs a 2. So I'm going to have 1 times x over 2x. Now I'm going to show that LCD here first, okay? Plus 2 times 2 and 2 times x equals, and on the right side, 2 times 1 over 2 times x. Now, here is the unique perspective. Because this is an equal sign, here's the shortcut. The shortcut is I don't need that denominator anymore. I get to ignore it because it's common now and I'm solving. Now let me show you why. Let's pretend like I don't know that, okay? If I did not know that, here's what I would do. On the left side, I would combine, right? I would have a 1x plus 4 equals, or excuse me, over 2x equals 2 over 2x, right? And let's say I forgot about that common denominator. I didn't know that rule. I would cross multiply, right? So you don't have to write this yellow part down. Let's just talk about it. Okay, 2 times 2x equals 2x times x plus 4. Now see what would happen if I have the same thing on both sides. If I divide it out, it goes away anyways. And I'm left with the numerator. See how that happened? So I still arrive at that answer. So we want to know that rule, right? This is a rule you can get around and not need, but oh, it makes your life so much easier, okay? So again, here's the idea. Once every piece has the common denominator, you no longer need it. You then take every single numerator and create your equation. Not too bad, right? So I'm going to arrive at an answer on this one of x equals -2. Now, as before, check for extraneous solutions. Plug it in, make sure it works. In this case, a half plus -1 would get me a -1/2. Like it makes sense, it works, it's good to go. Let's expand that, right? It's not always going to be that easy. Okay, I see in my LCD, I'm going to start prepping it. I see an x plus 1. Technically, this 2 is over 1. This denominator needs to be factored, x plus 1, x minus 1. So my LCD also needs an x minus 1. All right? So we're going to multiply each piece by what it needs. This first piece needs an x minus 1. This second piece has everything. I'm going to write a 1 just so I can write something. The second piece needs the entire LCD, which is technically x squared minus 1, right? If I was to FOIL this out. All right. I'm going to write it out with the LCD. Some of you will not need to do that. You'll understand the overarching concept. Okay, equals, a 12 stays as is, and it stays in x squared minus 1. And the third piece is going to be a plus sign, and we have a 2 times x plus 1, x minus 1, which is x squared minus 1, all over x squared minus 1. Okay, so I see that every single piece has the same denominator. I get to ignore it now. So let's take care of each numerator. I need to combine, I need to distribute. I'm going to have a 3x squared minus 3x equals a 12. Let's distribute that 2, so a positive 2x squared minus 2. I'm going to move everything to the left. So I'm going to subtract 2x squared. I'm going to have an x squared minus 3x. 12 minus 2 is 10, so I'm going to subtract that 10 over. So we've created our quadratic trinomial. Let's just factor and solve. All right, let's see, what could my factors be? I need to get factors of 10 that can get me to 3, 5, and 2. It needs to be a negative 5 and a positive 2. And remember, when we're solving equal to 0, we set each factor equal to 0. So I have 5 and negative 2. Let's check our work. Mental math, I'm just going to jot a few little notes down here. I'm going to have 15 over 6 equals 12 over 24 plus 2, 1/2. Let's see, this would be 6, 12. This would be 2.5. And this would be 1/2 plus 2. So that one's good. Let's try negative 2. Negative 6 over negative 1. 12, that'd be 4 over 3 plus 2, so that'd be 4. 6 equals 6. Awesome. Both solutions work. Let's try another one here. There's no factoring any denominators, so I'm going to identify my LCD. I have an x plus 1. That's an entire chunk. It's an entire binomial. It stays together. Times a 2 times an x, right? I don't need the other x because I already have one. So first fraction needs a 2 and an x. The second fraction needs an x plus 1. And the third fraction needs a 2 and an x plus 1. Now, I'm going to jump ahead here. If I am confident in my LCD work and I know I'm not going to need it, let's not even write it down. So my first fraction is a 2x times a 3x. I've got a 6x squared. Plus sign. 6 times x plus 1, I'm going to distribute that 6. Equal sign falls down. A 7 times a 2 times an x plus 1, which would be like a 14 distributed. 14x plus 14. All right, I'm going to move everything to the left side. Subtract 14x would get me negative 8x. 6 minus 14 would also be a negative 8. I'm going to divide out a 2 right away, try to make it a little smaller. And let's try to factor. Now, not everything needs to be factorable. I mean, typically we'll make it that way, but we can solve quadratics any way we know how. You could do quad formula and get the answer as well. But I see a 3x and a 1x. Let's see, 4 and 1 or 2 and 2. 2 and 2 get me a 6 and a 2. Yes. We're going to need a negative 6 and a positive 2. Let me double check. 3, negative 6, positive 2, negative 4, negative 4. All right. Let's set each factor equal to 0 and solve. I'm going to have 2 equal to 0. That's not true. So we don't even need that GCF because it's a single value. It's not a variable. 3x plus 2 equals 0 gets me x equals negative 2/3. And my last one would be x equals 2, because I'm just going to add that 2 over. So let's take a look. Negative 2/3 and 2. Now you can use your calculator to check, right? That's not a big deal. Here's the thing. When is it not going to work? Like, when am I going to have an extraneous solution? If one of the solutions makes a denominator 0. Just like before, if it makes the denominator 0, I can't use it. So in this case, you could check to make sure you're right, but they're going to work. All right, let's try subtraction. We haven't had like just a solid subtraction problem. So I'm going to put that over 1. I'm going to identify my LCD. My LCD is x minus 5 and an x. The first fraction needs all of it, the x and the x minus 5. The second fraction just needs an x. And my third fraction needs an x minus 5. Again, if I'm confident in my LCD work, I am not going to show my denominator because it's an equation. If it's an expression, you need it, right? I'm only ignoring it because it's an equation, and it would cancel out anyways. So, first fraction, be very careful. We're subtracting 8 times x equals 3 times x minus 5. I'm going to distribute that right away, actually. And I should have distributed this one right away as well. Let's see. X squared minus 5x. I've got a minus 8x. I'm going to move everything over to the left side, right? We want to keep that leading coefficient positive. So I'm going to have an x squared. Let's see, negative 13x minus 3 more will be negative 16x. Add the 15 over. Again, show more work if needed. I'm going to have factors of 15 that get me to 16. Well, 15 and 1, both negatives. I get an answer of 1 and 15. Now this one's super quick to check. 1 minus 8 over... I'm doing the 1 first, so negative 4, which would be negative 2 equals 3. Yep, check. 1 minus, this would be 8 over 10 equals 3 over 15. Let's see, 1 minus 8 tenths would be 2 tenths, which would be 1/5 equals 1/5. Perfect. Again, use a calculator. You could make sure the decimals are the same to prove it, but I am confident in my solutions. All right, let's look at one more example where we have to factor in the beginning as well. So I've got an x and an x, 3, 2, positive, negative. All right, let's identify our LCD. I think it's really good to write this part down. It just helps me visualize every denominator once. So the first fraction does not need anything it has. Now I'm going to put a 1 just so I have something there. The second fraction, which is technically over 1, needs every piece. Oops, plus. The third fraction needs an x plus 3. Now, if I'm confident in my LCD work, I am going to jump straight into not writing it down. I'm just going to worry about the numerator. So I'm going to have 1 times 5. I'm going to have 2 times those factors, but you guys don't refoil it. You already know that this is that foiled. So if I accidentally do refoil, no big deal, but let's save ourselves some work. It's 2 times that, plus I'm going to have an x minus 3 times x plus 3. So let's take care of distributing. Let's FOIL that, which is difference of squares. So I'm going to skip the outer inner. Oops, I forgot my squared here. Let's combine like terms. Let's kick that 5 over. Ooh, that is a large constant. So if I try to factor this, a 3x and a 1x, The factors of 26 are very limiting. There's no way I can get a 2 out of that. There are no factors that are close enough that I can get a 2. So I can't factor this. What are my options? Alrighty, we're going to have to quad formula or complete the square, but we have some work to do. So I'm just going to make some room on my screen here so I can take care of that. I'm going to approach it from, I don't want to do completing the square because I'd have to divide everything by 3. So I'm going to approach it using quad formula. All right, so opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. Let's simplify. -2 plus or minus. This would be a 4 plus, we got some multiplying. 4 times 3 is 12 times 26 would be 312. So I'm going to have the square root of 316. Oh my goodness, over 6. Let's simplify that 316. 4 fits in. I could reduce that down. 316 divided by 4 gets me 79. All right, so I'd have -2 plus or minus. The square root of 4 is 2. Radical 79 over 6. And I can reduce all 3 pieces by 2. So -1 plus or minus radical 79 over 3. Oh my goodness, how about that for a solution? Now, I don't recommend checking this answer. You want to be very confident in your work. This can happen. We're solving quadratics. It's going to happen. And I wanted to show you what that looks like when it does happen. All right, so thanks for bearing with me. I know this is a little bit longer video, but I wanted to provide an example of each type. Make sure you check Google Classroom to see what the task is to go with this. Let me know if you have any questions, and until next time, have a good one.